Teacher Neth, and welcome back to our Statistics and Probability class. Now that you know how to list the possible values of a discrete random variable through a probability distribution, this time, you will learn about some property of a probability distribution. These are mean and variance. The mean u sub x of the discrete random variable x is called the expected value of x. It is denoted by E of x. It is the weighted average of the values that random variable can take. Its formula is E of x equals mu sub x, or mean, equals summation of the product of x times and p of x, where x is the value of the random variable, p of x is the probability of the random variable x, and mu is the mean of the probability distribution. The variance and standard deviation describe the spread, dispersion, or variability of the items in a distribution. The formula for finding the variance is sigma squared equals summation of the product of x squared and p of x minus mu squared, or mean squared, where x is the value of the random variable, p of x is the probability of the random variable x, mu is the mean of the probability distribution, and sigma squared is the variance. On the other hand, the formula for finding the standard deviation is sigma equals square root of summation of the product of x squared and p of x minus mu squared, where x is the value of the random variable, p of x is the probability of the random variable x, mu is the mean of the probability distribution, and sigma is the standard deviation. Take a look at the following examples.
Example 1. A researcher surveyed the households in town A. The random variable x represents the number of children in the households. The probability distribution of x is shown below. So x represents the number of children in the households, and the corresponding probability of each, that the household surveyed has 2 children, the probability is 0.15, or that there are 3 children, it's 0.30 probability. And the probability that there are 4 children in a household surveyed, that is 0.55. So now, again, this is the probability distribution for the number of children, or probability that a household surveyed has this number of children. So we will solve for the value of the average, or mean, and then the variance and the standard deviation. So here is a table wherein the first column is for the x values, or the number of children in this case. And then p of x is the corresponding probability. So these 2 columns comes from this table, from the 2 rows. And then since we will be needing their product in solving for the mean, so we have this third column, which is x times p of x, or probability. When you try multiplying these 2, you'll get this product. 2 times 0.15 is 0.30, and so on. And then for the next column, we will be needing this x squared times the probability of x for the computation of the variance and the standard deviation. How do we get the values of this? First, you will square x. That is 2 squared times the probability. 2 squared, or 4, times 0.15. You'll get 0.60, or 0.6. And then 3 squared, 9, times 0.30, or 0.3, that is 2.70, or 2.7. And so with 4. Okay, going back to the third column, since the formula for finding the mean is the summation or total of this x times p of x, then you will just get their total, and that is 3.40. That is the value of mu, the Greek letter mu, which represents the population, the mean or the population mean. And since we are talking about the number of children, then that cannot be 3.40. That is approximately equal to 3. So 3 children. Therefore, the average number of children in the households of town A is approximately equal to 3. And then the value of this is the sum total of these 3, x squared times p of x is 12.10. We will be needing this in solving for standard deviation and variance in the next slide. This is the table that we created in the previous slide, where in the third column, we derived the value of the mean, which is 3.40, and we told that the fourth column will give us or will be used in solving for the variance and the standard deviation. So solving for the variance, this is the formula. Small letter sigma squared. Sigma squared is the symbol for variance. So variance is equal to the summation of x squared times p of x minus mean squared. We have a value for this already, and that is in column 4. And then for mean squared, that will be from the third column. We will just square this 3.40. So this is what we will form after substitution. The first term is 12.10, and then the second term comes from this 3.40 squared or mean squared. After squaring this, so square this first and then subtract it from 12.10, we will get the value of variance, which is 0.54. And then for the standard deviation, we know that the symbol for standard deviation is sigma without the square. That's from variance, sigma squared. So in order for us to solve for the standard deviation, when we know already the variance, we will just get the square root of the variance. By substitution, that is, standard deviation is equal to the square root of variance, or 0.54. Rounded to the nearest hundredths place, or 2 decimal places, the standard deviation is 0.73. That means that the values of the random variable defined by the observed number of children in households of town A or of a certain town are somewhat close to the average number of children for about 0.73 unit from the mean. Example 2. A milk tea store owner determines the number of milk teas sold each day. There are 20, 23, 19, 30, and 25 milk tea sold per day with probabilities of 0.18, 0.25, 0.17, 0.30, and 0.10 respectively. Find the mean, variance, and standard deviation of the given probability distribution. So first, let us create the probability distribution. The number of milk tea sold each day are in row 1 for the values of x, and the corresponding probability is in row 2. The probability that there will be 20 milk tea sold in a day is 0.18. That is given in the problem. And so on. When we convert that into another table, where the first column is the number of milk tea or the values of x. So these are those enumerated or given in the problem, in the example. And then the second row again is their corresponding probabilities. This is still given in the problem. And then the third row will be x times p of x, or probability of each x. To solve for the mean, we will just multiply this. So 20 times 0.18, this is the product, 3.6. 23 times 0.25, 5.75, and so on. And then getting their sum, you'll see that it is equal to 24.08, the value of the mean. And then for the fourth column, we will solve for x squared times p of x, where we will square the x first before multiplying it by the second column. Square this first and then multiply by the second column. That is 20 squared or 400 times 0.18. And you'll do that also to each pair here. And then this is what you will get. And then in the end, we will get their summation or total. You'll get the total of this, and that is 598.12. This written in blue, that's the average number of milk tea sold by the store owner in a day, which is approximately equal to 24, because there can be 24.08 milk tea, sold milk tea. So that is 24. The average or the mean. This is the table from the previous slide. We're done with the first, second, and third columns. We are now in the fourth, which we will use in solving for the variance and standard deviation. So again, for the variance, this is the formula, sigma squared, or variance equals summation of x squared times p of x minus mean squared, or mu squared. By substitution, we already have a value for this. This comes from the last row in the last column. And then for the mean, this is the mean squared. So by substitution, that is variance equals 598.12 minus 24.08 squared. Again, square this first, then subtract it from 598.12. The variance is 18.27. Solving for the standard deviation, the standard deviation is represented by sigma, and sigma is the square root of sigma squared, or standard deviation equals the square root of variance. That is equal to the square root of 18.27. And the standard deviation is 4.27. So the number of sold milk tea in 5 specified days are somewhat close to the average number of sold milk tea, for about 4.27 units from the mean.
In business, however small it is, in daily tasks or in any endeavor, keeping a record is essential. A little analysis of this recorded data will inform you of your progress, or sometimes it will remind you when you have to work harder and spend more effort. Mind you, having this little know-how of mean, variance, and standard deviation will keep you on track. Let's do things orderly. Until next time!